Outer space, the nothing in between the something actually comes in layers. Interplanetary space, the region inside a solar system shaped by the solar wind from the star at its center. But space stretches far beyond that. Interstellar space, the territory between solar systems outside any star's plasma bubble. Here, you're under the influence of only one thing: the supermassive black hole at the center of the galaxy. Sounds grim, but it gets worse. Intergalactic space, the emptiness between galaxies themselves. This makes up about 90% of the entire universe. And this empty space isn't consistent. It fluctuates dramatically. The best example? The Boötes Void, also called the Great Nothing. It's a spherical region roughly 330 million light-years wide. If you filled that volume with bananas, you'd get a ridiculous number, the kind you listed. But the point is simple: inside a space that massive, you'd expect thousands of galaxies. The Boötes Void has around 60. To understand how empty that is, we discovered the Andromeda Galaxy in 1923. But if the Milky Way were sitting dead center inside the Boötes Void, we wouldn't even have known other galaxies existed until the 1960s. That's how starved this region is. So why does this cosmic gap exist? To answer that, you need a basic sense of how the universe is structured. It's basically a cosmic sponge. Galaxies gather into clusters. Our Milky Way sits in the Virgo cluster. Zoom out, and clusters merge into superclusters like the Laniakea supercluster. We have zoom out once more, and even those superclusters are separated by enormous voids, the largest being the Boötes Void. So why does matter bunch up and leave behind these huge, empty regions? The short, annoying answer: tiny fluctuations just after the Big Bang expanded over 13.8 billion years, creating pockets of lower density. The long answer is more satisfying: wind the clock back to 10 raised to power minus 32 seconds after the Big Bang. The entire observable universe is unbelievably small. At that scale, quantum fluctuations, little bursts of energy appearing and disappearing, actually matter. Normally they're insignificant, but when the whole universe is this tiny, those random spikes in energy push things around meaningfully. Early matter and trapped light bounced around like a cosmic game of Pong. This chaotic back and forth continued for about 380,000 years until recombination, the moment atoms first formed. Once that happened, light stopped ricocheting everywhere and finally streamed outward freely. That's when the universe really began expanding into what we see today. We actually have an image of this moment: the cosmic microwave background. Basically the universe's fingerprint. Those little temperature fluctuations you see, they're the scars of those first quantum ripples. See, the universe started clumpy, so it grew clumpy. And the gaps between the clumps keep growing thanks to relentless expansion. Look on the bright side. One of those gaps is absurdly huge, and that's honestly pretty cool.